Dark matter is one of the most mysterious and intriguing topics in modern physics and cosmology. Despite decades of research, its nature remains undiscovered, and its presence and influence are felt throughout the universe. Let's explore what dark matter is, why it is so important, and how it affects the structure and evolution of the cosmos. What is dark matter? Dark matter is a hypothetical form of matter that does not interact with electromagnetic radiation, which means it cannot be seen directly. Its presence is only established through the gravitational effects it has on visible matter such as stars, galaxies, and galaxy clusters. Key features of dark matter. Invisibility. Dark matter does not emit, absorb, or reflect light. Gravitational influence. It interacts with ordinary matter only through the force of gravity. Prevalence. Dark matter makes up about 27% of the total mass energy of the universe, while visible matter makes up only about 5%. Discovery and proof of existence. The idea of the existence of dark matter emerged in the early 20th century. One of the first scientists to point out its presence was the Swiss astronomer Fritz Zwicky. In 1933, he studied the velocity of galaxies in the Veronica Hare cluster and found that the apparent mass was not enough to explain their orbital velocities. He hypothesized that there must be invisible mass in the cluster. Later in the 1970s, American astronomer Vera Rubin studied the rotational curves of galaxies and came to similar conclusions. The velocity of stars at the periphery of galaxies appeared to be too high to be held together by the gravity of visible matter alone. This confirmed the presence of something invisible creating additional gravity. Further evidence. Relic radiation. Studies of the microwave background of the universe left over from the Big Bang also support the existence of dark matter. Gravitational lensing. Invisible mass alters the path of light, distorting images of distant objects. Numerical modeling. Computer simulations of galaxy formation and large-scale structures of the universe show that without dark matter, their formation would be impossible. Characteristics and candidates for dark matter. Despite the large amount of observational evidence, the nature of dark matter remains unknown. The main hypotheses include WIMPs, weakly interacting massive particles. These are hypothesized particles that interact weakly with ordinary matter. WIMPs are actively searched for using particle detectors. Sterile neutrinos. These are more massive and weakly interacting versions of neutrinos. Actions. Hypothetical particles proposed to explain some anomalies in quantum chromodynamics. Modifications of gravity. Some scientists speculate that instead of dark matter, there may be an unknown form of gravity that manifests itself on larger scales. The role of dark matter in the cosmos. Dark matter plays a key role in the formation and evolution of the universe. Its influence can be divided into several main aspects. Formation of galaxies. Without the gravitational influence of dark matter, the density of visible matter would not be sufficient for the formation of galaxies and star clusters. Dark matter acts as a skeleton on which visible matter is assembled. Large-scale structure of the universe. Dark matter forms the threads that connect galaxies and galaxy clusters into what is known as the cosmic web. It is through its gravity that we observe these structures. Gravitational lenses. Dark matter creates effects that bend light from distant objects, allowing scientists to see its distribution, slowing the expansion of the universe. In the early stages of the universe, dark matter slowed its expansion, competing with the effect of dark energy, which, in contrast, speeds it up in later stages. Current research and experiments. the study of dark matter is being conducted on several fronts at once. Space telescopes, missions such as ESA Euclid and NASA Roman are designed to study the distribution of dark matter through gravitational lensing. Ground-based detectors, experiments such as Xenon 1T and LUX Zeppelin attempt to register dark matter particles. CERN, the Large Hadron Collider, LHC, is searching for new particles that may explain the nature of dark matter. Astrophysical observations, studies of relic radiation, galaxy distribution, and stellar motion are helping to clarify its properties. Mysteries and challenges. Although science has made significant advances in the study of dark matter, many unresolved questions remain. Why can't it be detected directly? All attempts to record dark matter particles have so far failed. What is its exact nature? Is it a particle, a field, or something completely unknown? How does it interact with dark energy? The interaction of these two mysteries of the universe remains a mystery. Significance to understanding the universe. Dark matter doesn't just complete the picture of the cosmos, it is at the heart of understanding it. Without it, it would be impossible to explain how galaxies formed, why the universe has such a structure, and what processes occur on large scales. Its study brings us closer to answering fundamental questions about the nature of the universe. Dark matter is the invisible architect of the universe. Its mysterious nature makes scientists search for answers, develop new theories, and conduct unique experiments. Each new discovery brings us closer to unraveling this cosmic mystery, and thus to a deeper understanding of the very essence of the universe. In my opinion, the study of dark matter is one of the most exciting and promising areas of modern science. It forces us not only to expand our understanding of the universe, but also to revise the fundamental laws of physics. Each step in its study is a step towards understanding how reality works in its deepest aspects. Therein lies not only the scientific but also the philosophical value. If you enjoyed this journey into the world of the mysteries of the cosmos, don't forget to subscribe so that you don't miss new interesting materials. Thank you for your attention and see you in the next issues. Its mysterious nature makes scientists search for answers, develop new theories, and conduct unique experiments. Each new discovery brings us closer to unraveling this cosmic mystery, and thus to a deeper understanding of the very essence of the universe.